Good afternoon. I'm Anto Budiarjo. Welcome to Monday Live. This is something that we do on Monday afternoons to figure out what the future is for smarter buildings. In case you're wondering who we are listed on mondaylive.org. And please note that the views expressed here are personal, not of any company or organization. Just keep that in mind as we chit-chat. And do engage with us with our conversations on Zoom chat, questions, comments, and we'd like to make it as interactive as possible. And this slide deck, if you need any of the links on it, is available on mondaylive.org right there on the homepage. So this being March of 2024, we are talking about Internet of Things, or IoT, in the context of buildings. That's really been the conversation this month. This is the third week of the month. And so our agenda today is we're going to have a normal chit chat, and then we're going to talk about IoT. Really, we're going to talk about how IoT and the sort of terms that we've been using the last couple of months sort of relate to silos. Silos is the sort of a pretty important concept for buildings because there are many of them. And so how does IT and IoT and BAS sort of deal with silos, maybe the same or different, just sort of comparing those. So hopefully we'll have an interesting discussion on that. And all of this is part of the conversation we started in February talking about OT, then moving on to talking about IoT this month. And all of this is sort of in the realization that these two sort of concepts are really sort of necessary for the April conversation, which is going to be about AI, which is obviously about using data in new ways that is all very exciting right now. So this is kind of the flow that we're taking. So we're in the middle of that. But before we get too far into that, hand it over to Ken for his opening comments. Ken.
Thanks, Anto. We had a real good meeting on Wednesday. We all get our heads together on Wednesday and try and put the program together for Monday. And we started talking about connection profiles, and there was some really good dialogue, and I tried to capture some of that. And Tracy went off to AI and asked its opinion, and quickly brought that back. So I basically went back over what we've been doing the last few months and tried to give some definition to connection profiles, cloud native, and IBB. So I put that document up. It's getting reasonably good play, and we're getting some other people posting on their network. So I always take that as a compliment. We dusted off our cloud native presentation from AHR, because I think that was a very good insight with 4, 5, I guess, major people talking about how they're moving into the cloud. So I think that's an important piece. IBCon has got a I get a kick out of these wheels. When I was going to tech, there was a thing called a train ductulator, and you move the things around and it sized your duct for you. And I'm not sure how come these circles became the standard format for displaying AI, but it does seem to be that's the tool. So IBCon has in their pre-con program has a program pointed right at AI in our industry. If you click on that slide, you'll get connected to that, and you think you can register for it as well. There's another one that's just the mind-blowing tools. It's just more general AI stuff. Mostly why I put these on my posts is they give me huge numbers that I don't normally get talking about all the stuff that we talk about. So we did a little bit of talking with the Realcomm folks, and if you want to be relevant and in touch today, it's got to have AI in it or some link to AI. But there is a lot of great stuff going on. The IBCon presentation is built around the Copilot, Microsoft's Copilot, and how powerful that's going to be with the Azure database. So anyway, some good information there. Back to you, Anto.
Thank you, Ken. So I came across this article, so I thought I'd bring it up here. It's a building in Brooklyn claiming to be first of its kind because it's all electric. It was built that way. It was built purposely to be all electric, so there's no gas or any other energy sources coming into the building. I've been seeing sort of comments about the fact that electrification is going to be increasing because of its value to carbon mitigation. But also, I've seen several comments about the fact that what's interesting about electrified buildings is that it's easier to control, and so that's kind of why I brought this up, and just sort of wondering, does this make these buildings fundamentally smarter or able to be made smarter with less effort? Do any of you know any of this? Electrification is a good.
Sorry, we had some good talks at Chicago AHR. Brad White is really leading in decarbonization and electrification. The Vancouver city has basically outlawed gas in new buildings, so they're really committed to it as well. But some of another side of it that comes out of it is using our analytics that we have to resize the building. If you're actually doing a retrofit of a building, which he's been doing a lot of, you don't need to plan for the worst conditions. The other thing that we're starting to see is a lot of hybrid systems. Since we have the carbon system in there, we can leave it in for those few weeks a year that it is extremely cold, and we actually need that incredible power. And so you got kind of the plug-in hybrid building design. But yeah, lots of good information. They just had a successful building retrofit. One of Arthur Erickson's, which is one of our famous local architects, one of his original buildings was converted to electric, and they got a lot of press on that. So yeah, it definitely is easier to control. But one of the key things that Brad points out is that what information we have from our BASs is extremely valuable when you resize it, because then you can actually see when do we actually use full heating, how much of the time. You get to resize all the equipment with actual data rather than theoretical data. So interesting twist.
You know, in New York, JP Morgan's new corporate headquarters is all electric, from the ground up. I'm not sure, what's in it or whatever, but the fact that when they decided to build a new corporate headquarters, a world showpiece, that they decided it was going to be all electric. So it'll be interesting to see how that evolves, and once it's up and running and all that, I think it'll be a really good use case to learn a little bit more about buildings and electrification.
I don't know if anyone else has been seeing it, but there have been a whole series of articles recently that we haven't seen in more than 20 years about how we're running out of electricity. The fact that reshoring of a lot of manufacturing facilities, the expansion of the semiconductor industry, solar manufacturing, just in general, apparently the projections that are 20-year late are finally catching up to us. And the thing that people don't talk about is the thing that made electricity abundant over the past 20 years is energy efficiency, particularly LED lighting. And I think that what we're seeing now is LED lighting has finally run its course. And as demand grows, I think it'll be an interesting intersection to see how we're going to go all electric, and where those investments are going to be made vis-a-vis the grid or the buildings.
or both.
Right.
You know, that's an interesting point you bring up, Jim, about I've started to see the same that is we're gonna run out of electricity, or we're not gonna have enough to support everything with, you know, whether it's vehicles or buildings becoming more electrified, but that's a good point you bring up. I forgot about that.
I'm not sure how real it is, whether it's just spin, either the fossil fuel industry. A lot of the problem was reported to be in the state of Georgia because there's so much new manufacturing moving there and opening up. But, you know, what hasn't been said is the largest investments in nuclear in the country over the last 30 years have all been in Georgia. So I'm surprised that that huge capacity they have down there isn't going to keep up.
Actually, another piece of this that I hadn't thought through is we're having incredibly low snowpack up here. And of course, all of our smugness is that we've got these nice tall mountains. We fill them full of snow all winter, and then we drain the water out and harvest the power. And we don't throw carbon in the air. Pretty smug position to be in, although our snowpack is like 30–40% of what it normally is, which is all tied to global warming. The problem is festering faster than global warming. It suggests that everybody east of the Rockies is suffering for water because that's their water supply. Basically in Canada, the water from that runs all the way to the Hudson's Bay. So everybody in between there is into a problem that they're not going to have enough water. A lot of people, because they haven't stored enough water, will have a problem. We probably got the same amount of precipitation, but it came as rain and it's all running into the ocean rather than us storing it in the mountains like we normally do. A simple thought, but it's scary when you think about it. I hadn't thought of global warming, you know, it kind of feeds on itself. So, okay, we have this situation that we have this tremendous amount of energy stored in the mountains, and you know, the drinking water is obvious, but the actual energy stored, and then when it warms up, that doesn't happen. There's a whole bunch of things that start to snowball. You don't want to think about it.
Let us stop thinking about it now. Enough for one Monday.
Yeah, that's right. You started it.
Sorry. But thank you. Okay, so on other things, just a slide to the links to the Smarter Summit. We had an AHR, and it's still the group is still working on the event at Relcom on the 19th of June. So stay tuned for that. The link board is as always. And any other thoughts before we move on? Hearing nothing. So Internet of Things, and so let's think about silos. So how do IoT, OT, and BAS deals with silos? And let's just have a conversation about silos. So last week we went through this animation that I'm just going to go through again very quickly. This is a scenario of taking Tracy Markey's company's EV or IoT. This is the architecture as it is now, and sort of seeing how that would morph into using IBB. So this is an IBB sort of version of it with the gateway put into the IBB, which then allows other IBB apps or other IBB platforms can potentially connect to that IBB, and users can be anywhere, which is kind of the thesis of the IBB. Users are location agnostic. And also the ability to use basically the IBB cloud to connect to a whole bunch of other applications, either if they're in the cloud, as indicated here, or other systems that's actually in the on-prem. And we also talked last week about the fact that there's code in all of these different systems in different places, and that is where one would implement the connection mechanism, which is the key part of the IBB. And really what the connection mechanism does is it creates these sort of blue lines that transcends all of these different layers. Okay, so that's what we went through last week, being new there. The thing obviously with this is that by design, it can get really messy. So that's kind of could be a typical way you'd end up with a picture, which is not really very nice and not very helpful. But the thing that we want to talk about is silos, and sort of the way what I'm sort of thinking of doing is how do we convert this into a view that is silo centric? And I think it's like this, because all of those systems that we previously talked about are basically these silos that we talk about. And generally, we talk about these silos on the left, the HVAC silo, fire, lights, energy, et cetera, so we know about all of these, but obviously towards the right-hand side are sort of silos that are more sort of enterprise-centric or cloud-centric. But because we now live in the sort of the cloud-native world, these silos are effectively equivalent because they're architecturally, they can be anywhere as we've depicted in the previous diagram. So is this useful? Because essentially what we're showing here is that the blue lines that was very confusing on the previous slide, it's actually nothing but the mechanism of connecting between silos, across silos. We all know that each of these silos, I think all know the HVAC silo really well. We know that within that silo, there's a whole bunch of stuff. There's a whole bunch of protocols. There's a whole bunch of data models. There's everything else. And there is a similar picture in basically all of the other silos. Right? So all of these silos have their own protocols and technology and rules and semantics. And the connection sort of mechanism really doesn't delve into any of them. It's really designed to go across all of these silos. So this is kind of one picture, one way of thinking about it. And IoT is obviously this one here, which is just in this view, just another silo, and we can talk about that. There's another way of displaying this, which is like this. And we've sort of used this pictorial to depict system of systems on Monday Live and other venues. And the other way that we've talked about showing all of this stuff is on the Smarter Stack. And I quickly did this a couple of hours ago. I'm not sure is that accurate from what was there before. But this is also a way of thinking about all of the different silos, all the different systems communicating with each other. And that's kind of where I got to. It's just to broadening up this sort of notion of all of these different systems that sort of in a way look complicated, but if you look at it from a silo perspective, they're not complicated. And again, if you look at these blue lines as being cross-domain, cross-silo communication, then you start to get a different view. I'll have to open it up.
So
Conversation.
So Anto, the problem I see is that it doesn't solve the one-to-many problem the way you've depicted it here, because the HVAC information, you're just showing it as going to lights or lights going to HVAC, however, but in reality, it could go to multiple things, the CMS, the ESG, the energy. So you can't predict ahead of time whether it's going to have a relationship between 2 silos or 5 silos. And the minute you start drawing those extra connections, it gets as messy as your original diagram. So right. I think it gives the wrong impression. It looks simpler, but in reality, you can't actually achieve this. That doesn't meet the requirement because you need to enable one-to-many.
Well, that's just a matter of redrawing the lines. And I was going to go say the same thing. It just looks like we just did an API from here to here, from there to there to there.
Yeah.
The reality is, if you focus on any one, pick CMS, it could have a blue line going to 1, 2, 3, 4, 5, 6, 7, 8, 9, all 9 of the other silos.
Yeah, exactly.
And that So there needs to be a slide that kind of shows that. Also say that being from Iowa, silos mean something. Silos by definition are a market where something valuable is kept and then made available to the market. So so I've always loved the concept of silos being a good thing, because that's where a market is made. And to the point of now let's zero in on one silo and say, instead of just connecting to one other system, it connects to all 9 other ones. You just become more valuable. Your commodity, if you standardize the way that you connect to the outside world, you've just made it yourself effectively a commodity. And in Iowa, it's corn mostly, but you've made yourself available to multiple markets by standardizing on how you go to market. So that's my Iowa pitch. Sorry.
So, Steve, just for a moment, your comment was mostly from a visual perspective. It's
Right.
difficult to depict the multipleness because it just becomes messy.
Yeah. But
It's
I
not
felt like
from a
you were trying to
concept.
solve the problem of the previous diagram, saying it's messy, and this is a way of simplifying it. And I'm just saying I don't think it misleads.
So one of the sort of interesting things about this is each of these silos represent an industry, represent a whole bunch of people that's been trying to do something, right? HVAC, Firelight, for many years. Typically, I think that's the way we should be thinking about these silos. And what was I going to try and say? Oh yeah, so there's an awful lot of sort of standards, data formats, structures, types, information, units, and things that actually exist in each of these silos that are actually quite different or not really relevant in either silos. Right, because if you think about the all of the sort of the data is likely going to be different in these silos because they do different things. So the sort of the question that I'm wondering is that if you have a sort of a connection between, let's say this one here, the HVAC and lights, right, which is implying connecting those 2 silos, do you use the terminologies of the HVAC, the sort of the one that's on the left, or do you use the terminologies of the lights, or do you use some other third-party terminologies in terms of understanding what data is actually needing to go between these silos?
So the data representation, if we've always talked about haystack or brick, are they not, in your mind, are they inadequate in some way to represent the data across these silos? Do they need further work?
They won't be adopted. They won't. The other domains will just disregard them, which is, I think, what Jim was talking about last week, which is there needs to be a new ontology of the connections.
Mm-hmm.
We're not going to go use the ERP ontology. I'm sure they've got one. They're not going to come use ours. We're not going to go use the ontology of fire. As much as we go try and sell the lighting system folks to try and use brick or whatever, might be a real hard sell. So as we were at LBNL, we talked about, the ontology and the format for the connections being, the next frontier of normalizing how systems communicate. Because nobody's going to put nobody's going to adopt the CMMS ontology.
So, Mark, you're very much involved with Haystack. Has Haystack been predominantly just HVAC, and it doesn't have you haven't seen it being applied in any of these other silos?
No, there are several working groups that are indeed working on haystack standards and tags and models and all that stuff in some of these other areas as well. So to answer your question, yeah, but like anything, they take a while, especially volunteer organization, you know.
Yeah,
So
I guess what I'm
that's
arguing, Rick, is why reinvent the wheel? Why not work with the standard bodies that already exist, like Haystack and Brick, and
It's just
get behind them?
well,
So
because
why?
these other places, they have their own ontology already also.
Yeah, and you know, I can say that the BACnet community has been working on life safety objects for fire and lighting objects for 15 years, and there is prior art there. However, there isn't as much prior art with ESG or CRM or ERP or CMMS.
Right.
So what Rick is saying is fundamentally true. We need to bridge these gaps, and really that's the place of connection profiles. But my point is that we need to have some common understanding of how those connection profiles would be used at that level, rather than have everyone make them up on the fly. And I'm not saying that we need a huge standardization process where we're going to sweat every detail, but rules of engagement for how connection profiles should be used to be respectful of the different ontologies and understand that these are different markets, right? That exist and they're mature and there's a lot of prior art. So, you know, boiling the ocean by trying to get everybody to standardize on one thing is a very difficult task. But if we use connection profiles and establish certain rules of engagement, maybe we can avoid restandardization, but have some common understanding of how we can come up with the information that should be preserved. Because I think that if you came up with half a dozen use cases for each one of these silos, you'd capture 80% of the value.
Right.
And I think that could be done without, you know, standardizing every bit or byte, which, as I said, we've already done, and it doesn't make sense to do that again, or you know, try to have a unified field theory here.
Is there has the work that's been done on connection profiles to date considered the challenge that you're posing, Jim, and that it's moving in a direction or is proposing a methodology that would allow that kind of flexibility?
I'm going to take that to Anto, but the answer is I don't think so, not yet, Steve.
Yeah.
Anto?
Okay.
Well, the mechanism itself does. The mechanism is specifically designed to be very loosely coupled, right? So it can accommodate any kind of payload. But the definition of the mechanism does not define the connection profiles. The connection profiles is something that gets defined by the industry, which is really what we're starting to work on at the IBB project and in the coalition. That has not accommodated the thinking, but the mechanism itself allows for it. And, I mean, it's kind of it sort of came up ultimately it came up in a call last week that, you know, if you're working with on a trying to think through a connection profile that goes from HVAC to something else, let's say energy. I know there's no one line there between the two, right? Where in HVAC, Tracy was on the call, so I was sort of thinking of snivets being the sort of landmark way of defining a type. Right, so a snivet or the equivalent BACnet thing would be very, very familiar with anybody in the HVAC, but not in somebody in energy. Whereas somebody in energy would be thinking more about kilowatt hours and sort of things that are more sort of, let's say, grid side, because it's an electrification sort of paradigm that we're going to, right? Will be those kinds of units or those kinds of point declaration. So if you do a connection between the two, do you use the snivets or do you use the energy ones?
Mhm.
In other words, are you trying to satisfy the consumer or the provider, or do we create a brand new one? And what Jim is saying, for God's sake, don't create a brand new one because we've got all this work that's already done. But how do we do it when we're actually purposely bridging two things that are not equivalent?
I would actually argue, Anto, that the first 5 things, HVAC, IoT, fire, lights, and energy, primarily turn on what I refer to as physical world devices or physical world analytics. And we actually have enough standards in those areas to do interoperability amongst those silos quite well right now. Where we completely fall down are the next 5: CMMS, social, ERP, CRM, and ESG. We basically have no rules of engagement for that. And so the connection profile certainly can be used to bridge the first 5, but to me, the business cases that need to be addressed first are the second 5.
So Jim, just thinking about April and AI, it would seem that AI tools might be a very powerful way to mine the data, and if the data is given somewhat sufficient context, I'm thinking it's going to identify, be able to extract what's needed. So I'm just saying, as part of how this thing gets approached is, so if I'm in social media and I want to know, what's the temperature in my space, I'm going to use a word like temperature, right? And that shouldn't be hard to. That's not. I mean, that's something we do right now in Haystack all the time, right? So AI should be able to quickly find and correlate that, and correlate it to the person. I'm whoever I am. I'm Steve, and I'm in this building. Tell me what the temperature is in my space.
Yeah, I mean, and in the movies, that would be great. But the real, when we get to the real building and the social needs to do that correlation,
Mhm.
we find out that the temperature sensors have all been value engineered out of the building. There aren't enough. I can't control the space temperature in the area because the mechanical systems don't exist in place to do so. So, I mean, yeah, we can draw the lines, but where humans have been needed in the past, and this is almost an engineering human, is to be the arbiter of what's even possible because of other historical decisions that have been made.
Right.
If there were temperature sensors and VAV boxes or terminal units controlling the temperature in all those rooms, that'd be a wonderful thing. So, maybe that works in Germany. Ain't
Right.
going to work here.
Mhm. Yeah. So there's the judgment factor of of knowing the relative, knowing how the building's been instrumented. So if there's really only 2 sensors for 30,000 square feet, it's got to know that, right?
Right. And I think AI could eventually know that, but I'm trying to identify more immediate value propositions.
Mhm.
And right now, I think the world is just wide open for connecting those enterprise systems to the physical world systems
Right.
in a way that has not really been done before. And I think there's tremendous value there, even in the short term, AI or not.
Mhm.
Isn't there, Jim, a sort of a very fundamental disconnect between what you're calling physical world analytics, which are things that are very precise? A thing is somewhere, something is either on or off. Things are very specific.
Right.
Comparing that with a lot of the stuff that we humans do, it's a lot of the stuff on the right-hand side of this is sort of more social, sort of related, where it isn't as precise. And we're trying to bridge those.
Right. So, I mean, so if you had a temperature sensor and you had one for the whole building, That's still a better bridge than none. Right?
Right, but then you could then argue, because there's a whole bunch of engineers involved in what's in the building, that you need that in Fahrenheit, or you need it in centigrade, or you need it in very specific ways. That has to be done. It has to be presented in that way, otherwise it doesn't work.
I think that the good works of everyone in the industry over the years, including BACnet, Lawn, Haystack, etc., has gotten us a long way of the way as to where we need to be to solve that part of the problem. Identifying the value proposition of how you're going to sell comfort in a building, or how you're going to quantify it, how you're going to quantify greenhouse gases. It's all these trade-offs that have to be made. And in fact, when you look at energy engineering, it's basically humans making a lot of approximations to come up with hard answers where a lot of assumptions need to be made. And I think we're a long way away from AI being able to make those assumptions effectively.
It seems like the conclusion we're coming to here is every use case is so specific, creating anything that is too standardized across silos is going to be a difficult task. Is that what I'm hearing?
Yes, but I think if we came up with a way about how to think about what needs to be included, right? So you can hopefully plan for the future in terms of the information you're going to provide or how you're going to provide it. Let me put it to you this way, Tracy. In my view, when one is looking at analytics of any physical quantity, you want to have in your mind, what are the possibilities? What can you do with that data before you start to collect it? Rather than just a statistical technique of gathering all the data and running through it with statistical techniques to see what I can ascertain from it. So the two different things. You have a preconceived notion of some of the things where you believe value will be. You don't have to rein them in that closely. Or you can do nothing at all except collect vast amounts of random data and try to go through it. And my point is that for every one of these silos, we can come to some kind of premeditated understanding of where some of the value propositions are, and we can collect the data accordingly, right? So I'm not gonna be able to do a high-speed canning line in a food factory with 15-minute interval data, right? I know I need millisecond data to do that. Those are some of just the basics in terms of how I sample the data, what I sample. And the fact is that we can figure that out to a large extent without getting into the weeds on how we represent a temperature, a pressure, a volt, an amp, etc.
So one of the things about drawing a sort of a silo diagram like this is the sort of realization that this line that represents HVAC2 lights that I'm pointing at really is only to do with how the HVAC silo and the lighting silo is combined to create some other value that was not actually possible either in the HVAC side or in the lighting side. But the silos can't do those things. I mean, this is the whole sort of thing about system of systems. Each system can only do what it can do. But when you start linking them together, you then get emerging capabilities that was not possible to do without them. And one of the things that I keep on coming back to is that, and how do you identify that, and how do you not measure it, but how do you think about it? And or is that looking at it way too much?
Well, there's a little bit of and I'm going back to Iowa again, there's a little bit of chicken and egg going on here. And that if I don't know that I can get the data, it doesn't do me any good to think about the decision I would make if I had the data, chicken and egg. So if I don't know what components are available from a math equation, it doesn't do me any good to invent some math equation that's going to make some decision better in a particular way. So
it does, Rick, if you can interpolate and come up with other data points to fabricate the ones that you don't have.
absolutely. And my major in college was analytics and data modeling. So making up data and then filling it back in with real data once you have it, awesome, got it. But we can't, what I've been on, the mission I've been on for 20 years is to figure out whether or not we're ever going to be able to get data out of these systems. And that's where, I mean, that's where we are on the edge of the front edge of that. And thanks to all the haystack and brick and things like that, a lot of the data from these existing systems will be some of the most available, most normalizable data on the planet, which is great. We'll be setting an example for the other systems.
Right. Yeah. So the CMMS example, I don't see why they wouldn't agree, the companies that make that software, why they wouldn't agree to integrate with haystack data. That's wouldn't seem to me to be a big challenge from an API perspective.
Well, there's not just CMMS. I mean, there's also GIS, there's BIM, there's huge industries that are all arguing for their system to be the center of the universe.
Yeah.
System of record.
Well,
So-
I think that's exactly the point, Rick. Who owns the value to the customer? I mean, one of the things about our industry is it's very hard work to do this detailed stuff. And, the people that are on our side of the fence in HVAC don't want to just mail the keys to that value to, somebody with one of these higher level systems that gets in the higher level eyeballs. So I think that there's a business competition thing here, which prevents some of this from happening in terms of who's going to be able to offer that value to customers.
Yeah. Guys, I don't want to lose sight of the fact, I don't think it's our job to engineer the systems. Okay. That's not going to happen. I think what I've always viewed about the connection profiles is something very fundamental. What data do you have? Tell me. And if I see out of that data, there's something I want to subscribe to it and send it to me when it changes. Okay. But that decision of whether I want it or not I've got to make that. That's an engineering step. I have to decide whether you have data that's relevant to the problem I'm being asked to solve. So in the case of, say, lights, and I got a CMS package, I want to know all my fixtures. Tell me what your fixtures are, right? And what's the wattage for each light bulb, right? So just some really fundamental information. So whether I decide to use it, again, it just comes back to what data do you have? And if you got data that I want, I'm going to subscribe to it. Think anything beyond that seems like is never going to work. We can't, because we're not, these systems are engineered uniquely for each and every building.
So you're saying, if I'm just making silos up, but if I'm a fire system, for example, technically I could, in your words, subscribe to some information from the CMMS just in case he has it, because I would then be able to do something different in my fire system.
Yeah, well, not necessarily do anything different, but I would, whether you get it as part of BIM when the system was originally designed, or let's say the system was engineered without BIM, right? But Simplex came in and installed it, and I just want to know how many fire detectors, smoke detectors do I have out there, and where are they, and I want to put that in my CMMS package so I know what I've got.
Yeah, so you can understand the periodicity when all those units need to be tested, right?
Exactly. Really basic stuff. So just I'm asking the question, what do you have? And if I think it's valuable for me as a CMS, because I own an asset tracking package, I got to decide which assets I want to track. So there you go.
So you've just described a CMMS system that is consuming information from the fire system,
Right.
where the heads are. so that the CMMS system can do its stuff,
Right.
do its function. Okay. So if that were to try to happen, if that was sort of one scenario, and the fire system provided its data in some weird, funky format that is only good for fire systems, you as a CMMS system, you're not going to like that. You're not going to know what to do with it.
Yeah, well,
Or
that's why I get back to the answer. That's I'm saying the rules of engagement are connection profiles. You have to give me the data. You have to model the data in a way that I can easily know what the
Right.
hell it is.
Okay, so but now we wind that back to we're now sitting, let's say this group is now sitting to define what the connection profile is to do that.
Right.
Right. Some point we're going to have to say in that connection profile, the information that you're going to provide fire system is going to be this type of information, this type of format, this structure, this scale, whatever it is. Right. Question is that done so that it's usable for the CMMS, or is that done so that it's usable and better for the fire system? The structure of the data, or does it matter?
I know, I mean, most of the fire systems all support BACnet already, as an example. So you can get a BACnet driver to most of the fire systems. So they're already used to the idea of presenting their data in a structured way. So as an example. So the question is, if if I've got all these, let's say I've got 5 different systems that all can give me BACnet data, how am I going to take that data and present it in the context of connection profiles? We thought about that.
There is a basis to all of this being successful, I think, in terms of being able to either ask for or describe the data in terms of a meaningful way to somebody else, right?
Right.
And every bit of data is going to, one of them might have 1 or 2 characteristics, others might have 15 characteristics that it needs to clarify, over and above basic units, for instance. So I think this is what you're saying, Steve. It's more important to understand the framework and how we ask and or describe that data than worrying about the combination of use cases or silos or data.
Right.
It's a process that is important here to connection profiles. If there is a standard way to ask for information and reply to a query like that,
Right.
that goes
Now,
a long ways to making it more open.
right, but at some point, that query is going to result in somebody saying, "Here's the data." Right, some point along the line. Otherwise, you wouldn't do it, right? What we have to agree ahead of time, we meaning we, the people who are writing this specific connection profile, we have to agree ahead of time what that format is going to look like. Because that's the whole idea of creating a profile, connection profile, is to define it.
Yeah. So I think we talked on Wednesday about having some kind of a standard, creating standard templates for these different profiles. Right. So you have a fire profile, and you've got a access control profile, and a lighting profile, and so on, so that each silo knows how to represent their data in the context of that profile.
Both from a provider and consumer standpoint, what I have and what I need.
Yeah, right. Yeah.
Right. Yep.
Could we start with just having it from HVAC using BACnet and over to lighting using DALI, and we create a relationship between those two known quantities, and we can only move as much data as each one of those contain.
Right. Yeah, exactly. I'm arguing, let's start with what we've already got and just morph it into a standard way of asking for it. A higher level standard of how you ask for it. Let me be more specific.
So really what you want to, in your thinking, should be saying, as the CMMS, I should be saying something along the lines of, give me, I'm looking for fire detection head information in BACnet.
Right.
Whereas another scenario, maybe I want to do that in Modbus if that thing exists.
Yeah, and I wouldn't, you know, again, I wouldn't be opposed to the data, just saying I need the fire, all the smoke heads, fire heads, in your system. Really simple. Whether they come through via BACnet or they come through via Modbus, do I really care? If the connection
Well,
profile has the mechanism,
at some point, some code somebody's written is going to care, right?
Right.
Ultimately, from a systems perspective, you don't care.
Right.
But at some point, somebody's going to get a bit of data and they're going to have to read it. So they have to care. Somebody has to care.
yeah, I'm just suggesting that a profile is also a piece of code that is essentially its own separate data base that these systems can write the data to. And then when you see what's available in that profile, you subscribe to the subset of points that you want.
I think if we start with existing standards, we can move faster because we can actually do something. And I think the other, Jim brought up a point a while back, maybe in last week's meeting, about the importance of the standards we have created. And this actually will bring a greater value to them. If there is an actual connection profile to connect BACnet and DALI, then that would be useful. And then it forces me to make more BACnet points and more DALI points.
That's an interesting way of looking at it.
I think it's a good place to start, and then there'll be the a haystack version and the lawn version and all the other ones
Yeah,
will come.
right.
And that, but what it'll do is it forces the silos to, we don't care, we understand you're a silo, but come up with a standard that you want to use in your silo.
So just play that out. I love the way you left it there. If the CMMS industry, I'm not sure it really exists as a thing, comes along next month and says, here's a CMMS X standard that we've all agreed to, we can then go ahead and implement connection profiles to them. Right? That's basically what you're saying.
And you have many working on the problem rather than a few.
Well, this is again, it is being worked on in other industries and other areas. And that's where, again, as the coalition, we're saying we're going to use cloud native CNCF as a way of centralizing with the work we're trying to do and encourage, because we know that that's the same set of tools that's being used in the other industries, in the other silos. So, and sort of, desperately saying, let's get some examples of our industry into some templates, because we are having conversations with those other folks, with the CMMS, GIS, BIM. We are having those conversations, and we're trying to say, we're getting our act together. And we just need some examples to be able to show to those folks of, here's how we're going to ask for data. Here's how you can provide it. We're in a position to be in the leadership role to do that. And again, that's why using the same base tools for coding and for data manipulation and databases and resource allocation, containers, Kubernetes, CNCF tools, we're already close cousins to be having systems that will work together. We just now have to put the same icing on all the cakes. That was not an Iowa reference.
So let me ask you guys this. So what you just discussed, interesting perspective. Turn this back to IoT. Over the years, hasn't IoT tried to do this with the various groups as IoT, gave birth to itself from various standards like Thread and all these others? I don't remember all of these. And didn't they try to do the same thing? And unfortunately, they couldn't get the people who produced the technologies, who produced the solutions, to engage and adopt that stuff. Way too many.
But things like thread and matter are essentially at the different level. They're network level stuff, right? They've gone through
The concept is still the same, right?
Sorry, what?
Concept of data utopia.
Yeah.
Is still all the same. They're bits and pieces. You still need the network stuff for it to do.
Yes, indeed. But there's no initiative, to my knowledge, on the IoT side of things that has in any way tried to create a way for different IoT systems to talk to each other that were not originally designed to do so. I think just the way IoT
Tried years ago. Again, I don't remember, but anyway, who knows? You know, but this has been the reoccurring challenge. Met all of us in this on this call, including our guests. You know, we've all been doing this, trying to do this for years, haven't we? And it sounds great on paper. It does. And why wouldn't you? And to me, ultimately, it's protecting one's turf and the business model. If I'm
of the silo, of whatever silo you're thinking about.
Yeah.
Yeah.
HVAC. All right. So there are how many manufacturers of HVAC equipment and systems, X, whatever that is, and everybody's built their business a specific way. They go to market a specific way or whatever. And ultimately, what's going to produce the big green bucks that we all.
Well, that's where I think we can take it back to Rick's initial Iowa comment that a silo is a market. And ultimately, what silos need to do is to deal with other markets, because just having grain is not very useful. You could have other things to put on your table, kind of a thing. No, it's just a component, right? So the combination is really what's important. So if we just totally focus on the silos, I'm not sure we're getting the perspective that the building owner is wanting, which is really multiple silos, because his building is made up of multiple silos.
Look at the comment Mike just made, and a few others, and David or whatever. Going back to some of these comments.
Spot on.
Mm-hmm.
Give the Foxonomies their freedom, which is the reference to something like Haystack, is sort of kind of like that.
Just that simple.
Thank you, Mike.
So.
Okay. Anybody feel like wrapping up on silos? My head hurts.
Yeah, I'm more confused than when I started. I'm not sure if I could summarize it.
So let's add this subject, silos, to the presidential debate and see what the hell happens, right?
I think the fundamental challenge with silos is, from a market standpoint, is each one creates turf, learns to protect the turf, fulfill the needs of that turf. Otherwise, they go out of business, right? So they're highly focused on the market they're in, and because everything has gone digital, in theory, they have information that should be accessible. In theory, so but even if they create some way for them, and they do create mechanisms whereby you can grab that data, how the data gets represented is, in almost all cases, unique. in many cases. I mean, we've started to standardize on in the HVAC side with, Haystack and BACnet and such. But if I'm in access control, it's a whole different universe. So that's the nature. It's the nature of silos. So the question is, what can we do to create a mechanism that any silo can use to declare its data and make it accessible? What can we do to accomplish that?
And sort of the other part of the thing that you said at the beginning that I wish you would have gone and said is that people are focused on their silos, and it's almost like they don't care. Nobody cares about what happens in any other silos.
Right. Yeah.
Because you don't. I mean, you and
don't.
your industry care about this silo. You fight amongst yourself to compete against the silos. You don't care about the other silos.
Yeah, it's the nature of the beast.
But yet we now want to be introducing value that is not directly related to your silo. It's actually directly related to how your silo is going to work with some other silo.
Right.
Actually, it's going to improve your silo.
Mhm.
But it's your selfish, the sort of the self thing, it's gone away.
Oh, but everyone that wants to compete at an enterprise level wants to do exactly that, Anto. So it's it depends on who you are and how you're trying to redraw your lines. All of the large companies in the industry have a digital transformation plan to try to harvest this value and delight the owner that way. Whether they have any substance in getting there is they probably just don't. I won't even say it's another matter, but a lot of people have that in mind.
And looking at the time, we're out of time. So this has been quite an interesting conversation.
Frustrating to say the least.
Exciting.
Okay.
It hasn't been done before.
Yeah.
There you go. It's been good. We'll follow it up with something next week. I'm not quite sure what. I hope everybody gets a good week this week, and we'll get the recording out tomorrow or Wednesday. With that,
Cheers.
well,
Bye.